Welcome to Short's classes. Today we're going to be dealing with some sampling questions on practical statistics. Please WhatsApp or call us at the number given on the screen for any doubts or for full videos on our courses. The first question we are given with the following information. Suppose that a person has 3 sons. The number of cars they own for their business are as follows. Now we need to select 2 sons at random with replacement from 3, and we have to obtain the sampling distribution of mean number of cars and its expectation and variance. Also we need to verify whether expectation of sample mean x bar is equals to population mean and variance of sample mean is equals to population mean square, population SD square mind be by n. We calculate the population mean mu equals to 4 plus 6 plus 3, that is the value given for number of cars, and whole divided by 3, which comes to 4.33. Now doing it same for the sigma square, which is equals to 4 square plus 6 square plus 3 square whole divided by 3 minus 13 by 3 whole square, which is equals to 1.6. Here the total number of possible samples equals to 3 square, which is equals to 9. All possible samples, values of the sample mean and probabilities will be shown in the following table. Thus starting with 1 1, the sample values are 4 4, sample mean is x bar 4 and the probabilities are 1 9. Next 4 6 5 1 9, 4 3 3 which is comes to 3.5, the probability is 1 9, and proceeding as further we obtain all the probabilities, and upon addition we see it comes to 1, hence the probability is mutually exhaustive and thus there are no errors. Now the possible values of x bar from our previous table are 3 and the probabilities are 1 by 9, 3.5 2 by 9, 4 1 by 9, 4.5 2 by 9, 5 is also 2 by 9 and 6 1 by 9. Again we check the probabilities by addition and it comes to 1, and hence there are no errors. This is nothing but the number of times these means arrived in our previous table divided by the total number of samples that we had obtained. Now we have all the tables in one go. We have all the possible values of x bar and the probabilities of them from our previous table. Now the possible values into their respective probabilities are taken in the third column, and upon addition it comes to 4.33. Thus, as we know, expectation x bar is equals to summation r into PR, which is equals to 4.33, and this equals mu, and hence our first proof is done. That is, the population expectation of the sample mean is equals to the population mean. Now variance of x bar equals to summation r into r square PR, that is our fourth column, minus 4.33 square, which is equals to, upon calculation, 0.8. Now sigma square by n equals to 1.6 by 2, which also equals to 0.8, which is same as variance of x bar. Hence the result, expectation x bar is equals to mu and variance of x bar is equals to sigma square n at SRS WR is verified. Now in the next question, the following histogram shows the sampling distribution of three estimators. The true value of the population parameter is given as 8. We need to figure out which of the above estimators are or is unbiased. Let's see. Estimators 2 and 3 are unbiased. The reason being, since the distributions are centered around the actual value. Notice the population parameter mu is equals to 8. Even for the third one, it is clustered around the central value. Also note that estimated 2 has a smaller variability compared to estimated 3. Now, in the next part, we see on the scales of 3 sampling distribution, which is more precise than estimator 1. Why or why not? Estimated 3, or like in the question, Roman 3, has high variability than estimator 1. Hence, estimated 3 is less precise than estimator 1. But there is a condition that we need to keep in mind. Estimator 1 is a biased estimator. With this, we come to an end of another great video. Please like, subscribe, and WhatsApp or call us for any doubts or for full videos on our courses. This is the number. Please contact us.